In lesson 5.4, we're going to be talking about conditional probability, which is probability based on a condition. What do you know? So we're going to start with our data from the taco tongue and evil eyebrow data collection. This is actually just data that I pulled from a previous year. Since every class's data was different and I wanted to make this video, I just thought I'd start with some basic data. So we have our Venn diagram and two-way table. So maybe pause this video and go ahead and copy those numbers down on your page. In number one, we are finding the probabilities listed below. So this first one right here, we are finding the probability of yes taco tongue and yes evil eyebrow. So as we talked about last time, when we have an and, we're going to just look at where those two things kind of intersect on the table. That would be right here. In the Venn diagram, we're looking at where the two circles intersect, which is the 15. So that probability would be 15 out of the total number of people, which is 30. So 15 out of 30 is 0.5. Right, probability of yes, taco tongue, and no evil eyebrow. Again, we would find that intersection where, I'm going to erase these highlights first. We'd find where those two things intersect on the two-way table. So yes, taco tongue is this row, no evil eyebrow is that row, so it's 5. On the Venn diagram, we want yes, taco tongue, so we want to be in this circle, but we want no evil eyebrow, so we want to be outside of the other circle. So we're talking about the 5. So 5 out of the total number of people, which is 30, and 5 out of 30 is something, should have my calculator handy, 0.17, we round it, right? Again, yes, evil eyebrow, I don't need to find any intersection, I just want the total number of people who are evil eyebrow, so that would be 18 out of 30, and then not evil eyebrow would be the total number of people who cannot do an evil eyebrow, which is 12 out of 30. And just to do those maths, 18 out of 30 is 0.6, and 12 out of 30 is 0.4. So that is number 1. So on number 2, we are saying, given that the person selected is a yes evil eyebrow. When we have a given, what given means is that we are no longer talking about the total number of people in the class. We are now only talking about this subgroup of people that is given. So given that the person is yes evil eyebrow means I only am looking at this column where the yes could do evil eyebrow. In the Venn diagram, that means I'm only talking about the circle of people who were a yes evil eyebrow. Those are the only people that I care about. So given that, out of that group of people, what is the probability that they are a yes taco tongue? So if I'm only looking at this column, I can see that 15 of the people could do a taco tongue in that column out of 18 people total. So again, I'm no longer talking about that total of 30 people. I'm talking about just the ones who can do an evil eyebrow because that is what was given. Okay, again, in the Venn diagram, only looking in that circle, these 15 are the ones who can do a taco tongue, and there's 18 total in that circle. 15 out of 18. So that is called a given or a conditional probability. The way that we can write that out at the beginning is we could say we are finding the probability of taco tongue given, we sometimes use this line right there to represent given, or you might use the word given, either one is fine, evil eyebrow. So we are finding the probability that someone can do taco tongue given that they can do evil eyebrow. And then 15 out of 18, if I calculate that on my calculator, is 0.83. So that would be my answer for number 2. So now we're going to try number 3. So given, so again, that's our given, that the person selected is a no evil eyebrow. So now we're not talking about the yeses, we are talking about the no's. So I'm going to erase those circles. So now we're talking only about the people who were a no evil eyebrow. And in my Venn diagram, the no evil eyebrow is everyone that is outside of that circle. So that's all these people who can do neither are part of that. So everyone that's outside of that evil eyebrow circle are people that I'm interested in right now, right? So out of the people who were no's on evil eyebrow, we want to find the probability that they are a yes taco tongue. So if I'm looking at the table, in that column, 7 could do a taco tongue out of 12 total. So we have five, I'm sorry, I said 7 and it was 5. 5 people could do a taco tongue out of 12 total. If I'm looking at the Venn diagram, in that yellow shaded area, 5 could do a taco tongue, and there are 5 plus 7, so 12 total in that shaded area. So 5 out of 12 would be my answer. And if I do my calculations, 5 out of 12 is 0.42 if I round it. Right, and the way we would write that, probability of taco tongue given, I'll use that symbol this time, and we said that they could not do an evil eyebrow. So remember the C means not, so taco tongue given, not evil eyebrow. That's how that would be written. And then we have this question that says, is someone more or less likely to be able to do a taco tongue if they can do an evil eyebrow? And I can see that when we were given that they could do an evil eyebrow, they were 83% of them could do a taco tongue. Whereas when they couldn't do an evil eyebrow, only 42% could do a taco tongue. So yes, right, people are more likely to be able to do a taco tongue if they could do an evil eyebrow compared to if they couldn't. So if A equals yes, someone can do a taco tongue, and B is yes, they can do an evil eyebrow, A and B are independent means that the probability of A equals probability of A given B, which should also equal the probability that A given not B. All of those would be the same. So we can kind of see that here. Taco tongue given evil eyebrow was this. Taco tongue given not evil eyebrow was this. Those are not equal, so they are not independent. In this example, we have a larger group of people, but same question. So I'm first going to take the information from this table and put it into the Venn diagram. So I always like to start with the intersecting section in the middle. So I'm going to look at the people who can do both, which is 180, and that's what goes in the middle. Okay, this section over here will be the people who can do a taco tongue but cannot do an evil eyebrow. So that would be those 300 people right there. And that way, this entire circle adds up to 480, which would be the total for taco tongue. And then the people who can do an evil eyebrow but not a taco tongue would be those 20 people right there. And then our whole eyebrow circle adds up to 200. And then out in the outside of both are the people who can't do either, which is the 100. So that's how I can fill in a Venn diagram if I have the two-way table already. So there is my information. So we're going to answer each of these following probabilities. So for part A, probability of yes taco tongue. So overall we have, oops, that's the wrong number, 480 who can do taco tongue out of 600 total. So this is not a given anything, this is just out of everybody. I can tell that because I don't have that little line right there that means given. So 480 out of 600, which is 0.8. Okay. On the next one, we are now dealing with a given or a conditional. Remember this line right here, that line means given. So this is saying, yes, taco tongue given evil eyebrow. So what that means is whatever I'm given, whatever comes after that line is what I'm going to look at. So yes, evil eyebrow is what's given. So I'm going to highlight that in my Venn diagram and in my tree table. Two-way table. So given that they can do evil eyebrow, we want the probability that they can do taco tongue. So I can see there's 180 who can do taco tongue out of 200. Or if I look at the Venn diagram, these 180 can also do taco tongue out of 200 total. So 180 out of 200 would be my answer here, which is 0.9. And then the next one, probability of yes taco tongue given no evil eyebrow. So now what I'm highlighting is the no taco tongues because that's what's given. So I'm going to do everything except the evil eyebrow. So that's everything outside of this circle. And then we want probability of taco tongue. So there are 300 taco tongue out of 400 total in the two-way table. And on my Venn diagram, 300 can do taco tongue out of 300 plus 100 is 400 total. So 300 out of 400 is 0.75. So then it says, are yes taco tongue and yes evil eyebrow independent? So because these are all different probabilities, that means no, not independent. Okay, so independent, what that would look like is the overall probability that someone can do taco tongue, which was 480 out of 600, would be the same in all three of the sections. So for example, right, 480 out of 600 is 0.8. So that means whatever this number is out of 200 would need to be 0.8. Whatever this number is out of 400 would need to be 0.8. We would want them all to be 0.8 when I do that. So to figure that out, I have to figure out what out of 200 is 0.8. So I'm going to do a little algebra over here. What out of 200 is 0.8? And to figure that out, I just have to multiply. So 200 times 0.8 means that you would want 160. So if 160 were up here, and then we'll do the same thing for this one. What out of 400 would give me 0.8? So then I can just multiply 400 times 0.8 is 320. So 320 would go up here. And then I could just do simple subtraction. 160 plus what is 200 would be 40. 320 plus what is 400 would be 80. And now to prove that it worked, right? Yes, taco tongue overall was 480 out of 600, which was 0.8. Taco tongue given evil eyebrow, so only looking at that row, 160 out of 200. If I check that, 160 out of 200 is 0.8, just like I wanted it to be. And then taco tongue given no evil eyebrow means I'm highlighting that row. So 320 taco tongues out of 400 total, which is 0.8, which is exactly what we wanted it to be. So now that all three of those are equal, that means now it is independent. So that's how we could force it to be independent. So we'll fill in our key concepts to finish us out. So our first concept is conditional probability. So probability of A given B. So I'm going to rewrite that just so we remember what the line means. So probability of A given B. Essentially, given B means out of those possibilities. So not out of the total, but out of those B possibilities, we're finding the probability of A. So out of B, what is A? Okay. Our second concept is the concept of independent. So independent, if we know one event has occurred or not has occurred, does not affect the probability of the second event. So in other words, if one thing happening or not happening has no effect on whether the second thing happens, that means they're independent. Basically, we want to show, does the probability of A equal the probability of A given B, which also equals the probability of A given not B. Okay, if B happening or not happening has no effect on probability of A, then we know those things are independent. Okay, because B has not affected A in any way. So those are our key concepts and some examples. So we've got some problems down here. I'm going to post the solutions and then so you can check your work during our lesson today. And that is what we'll do. And we'll go over this more next class.